Welcome, my friends. In this video, I will introduce the unit circle, which is something that you will use throughout your trigonometry course. The unit circle looks something like this. It is a circle that is centered at 0, 0 on an xy coordinate plane. There are a few points on the circle that are easy to identify. Since the radius is 1, if we move 1 unit to the right, we will be at the point 1, 0. If we move straight up, we will be at the point 0, 1. Moving straight left, we would be at the point -1, 0, and moving straight down, we would be at the point 0, -1. We can also associate angle measurements with each of these points. We typically view the positive x-axis as our starting point, so we let that equal 0 degrees. So the point 1, 0 is associated with 0 degrees. Then we typically move counterclockwise. So if we move counterclockwise up the circle, once we hit the point 0, 1, we would be at a 90-degree angle with the positive x-axis. So we associate 90 degrees with the point 0, 1. If we move all the way over here to the point -1, 0, that would be 180 degrees with respect to the positive x-axis. So we associate the point -1, 0 with 180 degrees. And then if we were all the way around to this point down here at 0, -1, that would be 270 degrees. And then finally, if we went all the way around the circle, that would be 360 degrees. So we can associate the positive x-axis with either 0 degrees or 360 degrees. They both represent the same angle. Angles that represent the same direction are what we call coterminal angles. So the angle 0 degrees and the angle 360 degrees are coterminal angles. We can also express each of these angles in radians. So 0 degrees is the same thing as 0 radians, and 360 degrees is the same thing as 2 pi radians. Remember that all the way around the circle can be expressed as either 2 pi radians or 360 degrees. That means halfway around the circle, associated with 180 degrees, would just be pi radians. That means 90 degrees must be half of that, or pi over 2. And then 270 degrees is equivalent to 3 pi over 2. Now the 4 points that we have found so far of 1, 0, 0, 1, -1, 0, and 0, -1 are associated with what we call the quadrant angles of 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Next, we are going to work on finding other points on the circle that are not quadrant angles. So assume that we draw a radius from the center of the circle to some arbitrary point somewhere on the circle. How about over here? And we would like to find the x and y coordinates of this point on the circle. Well, we can actually create a triangle out of this picture if we drop a perpendicular down to the x-axis. So this is going to be a right triangle. Let's blow this up over here to the side. We're going to have a right angle here, and we're going to have some x-coordinate. So the x-coordinate is on the base of the triangle. That is the x-coordinate of this point. And then we'd have some y-coordinate up the triangle. And therefore, the point up here is going to be x, y, and that is what we would like to try to find. Now think to yourself for a second, what is the length of the hypotenuse of this triangle? Well, remember that the hypotenuse is just the radius of the circle, because from the center of the circle to any point on the circle is the radius. And since this is a unit circle, the radius is equal to 1, which means that our hypotenuse is also equal to 1. Let's work with this angle right here, which we can call theta. Let's try to find the 3 primary trigonometric ratios with respect to theta. Cosine of theta is adjacent over hypotenuse, which will just be x divided by 1. So cosine of theta is x over 1, which is the same thing as x. If we want to find the x-coordinate on the unit circle, just take cosine of theta. Sine of theta, on the other hand, will be opposite over hypotenuse, or y over 1. So sine of theta is equal to y over 1, which is just y. So in order to find the y-coordinate on the unit circle, just take sine of theta. So therefore, to find the coordinates x, y on the unit circle, all you have to do is find cosine of theta, sine theta. Now we can also find tangent of theta. Tangent of theta is opposite over adjacent, which would just be y over x. But since sine is y and cosine is x, tangent is just sine over cosine. This turns out always to be the case even if you don't have a unit circle. Let's summarize what we've talked about so far. We have a unit circle, which means that we have a circle that is centered at the origin with a radius of 1. That allowed us to find some easily identifiable points on the circle: 1, 0, 0, 1, -1, 0, and 0, -1. Each of these points is associated with an angle measurement that is measured counterclockwise from the positive x-axis. So we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees for all the way around. And we also have the radian equivalents of each of those degree measurements. If we draw some arbitrary radius out to some point on the circle, we can find the x and y coordinates of that point by drawing a triangle and figuring out the trigonometric ratios. We found that cosine of theta gives us the x-coordinate and sine of theta gives us the y-coordinate. Alright, so now instead of working with a general angle theta, let's look at a specific angle of 45 degrees. If this angle is equal to 45 degrees, that means this angle must also be equal to 45 degrees, so that the three angles together add to 180 degrees. 45 plus 45 is 90, plus another 90 is 180 degrees. And the interior angles of a triangle must always add to 180 degrees. Hopefully you recognize this as the special right triangle of a 45, 45, 90 degree triangle. On a 45, 45, 90 degree triangle, the base and the height are equal, and the hypotenuse is equal to x times the square root of 2. We can use this to solve for the base and the height. We already know the hypotenuse is equal to 1, because that is the radius of the unit circle, which is equal to 1. So we can set 1 equal to x times the square root of 2, and then we can solve for x. Let's divide both sides by the square root of 2. The square root of 2 here will cancel, and we will just be left with 1 divided by the square root of 2 is equal to x. Now this is considered to be an improper form. We would prefer not to have a square root in the denominator. So the way we can fix this is to multiply by the square root of 2 divided by itself. This is what we call rationalizing the denominator. On the numerator, we will have the square root of 2, and the square root of 2 times the square root of 2 in the denominator will just simplify to 2. So therefore our x, or our base of the triangle, is equal to square root 2 over 2. But since we have a 45, 45, 90 degree triangle, the base and the height must be equal. So our y-coordinate is also square root 2 over 2. So that means that this point on the circle must be the square root of 2 over 2, comma, square root 2 over 2. And this is associated with a 45 degree angle, or pi over 4, which is the equivalent in radians. Now, you might be wondering why I didn't just use cosine of 45 degrees and sine of 45 degrees to find the points x, y on the circle. Well, I could have done that, but I would not have gotten exact expressions. If I want to know the exact expression, not a decimal approximation, I had to use the special right triangle. So that is why I use that approach. Okay, let's try another angle. Let's say we have a 60 degree angle. I'm writing the angles right on the lines rather than down here where we typically would put them, because it gets a little bit cluttered if I write all the angles right down here. And we're going to have quite a few angles once we're all the way done with this unit circle. Okay, so our goal is to find the x and y coordinates on the unit circle at this point right here. Again, we could use cosine theta, comma sine theta, but that will not give us an exact expression. That will give us a decimal approximation. If we want an exact expression, we will need to draw a triangle. So here we have our triangle if we drop a perpendicular down to the x-axis, and we can blow up this triangle on the side. So we have the 60 degree angle. Right here we have a right angle, which means that the missing angle must be 30 degrees, so that the three angles together add to 180 degrees. The hypotenuse is going to be 1, because that is the radius of the circle, and this is a unit circle with a radius of 1. We want to find the x and y coordinates associated with this point right here. So x is the base of the triangle, and y is the height of the triangle. Now hopefully you recognize this as a 30, 60, 90 degree triangle, which is a special right triangle. The hypotenuse is equal to 2x, the base is x, which is just half the hypotenuse, and the height is equal to x times the square root of 3, or the base times the square root of 3. So if we take a look at our hypotenuse, we see that our hypotenuse is 1, which is equal to 2x. And we see that the base is half of the hypotenuse. The hypotenuse is 2x, and the base is just x. So that means that the base must be half of the hypotenuse, or half of 1, which is just 1/2. The height is equal to the base times the square root of 3. So if we take the base of 1/2 and we multiply by the square root of 3, we will get the square root of 3 over 2. Therefore, if we have a 60 degree angle, the point on the unit circle will be 1/2, comma, square root 3 over 2. The radian equivalent of 60 degrees is pi over 3. Okay, the last angle for which we would like to find a point on the unit circle is going to be 30 degrees. Now, I'm not going to draw the triangle out for this one, but you can imagine that we would still get a 30, 60, 90 degree triangle. It's just that the 30 and the 60 degrees would be switched around, which means our base and our height would also be switched around. If you were to go through the process, you would find that the coordinate points would be the square root of 3 over 2, comma 1/2, which is just the opposite of what we had for 60 degrees. The radian equivalent of 30 degrees is just pi over 6, so we can include that on our circle. Okay, at this stage, we have derived the important points on the first quadrant of the unit circle. Your next task is to memorize these points. And I'm not joking about that. It really is very important for you to memorize what these points are. They come back time and time again all the way throughout trigonometry and calculus, so it's definitely worth your time to memorize these points. So let's first focus on the y-coordinate. So as you move up the circle, the y-coordinate increases. We go from 0 to 1/2 to square root 2 over 2 to square root 3 over 2 to 1. So notice that each of these different points kind of in the middle of the circle are divided by 2. So we have 1 over 2, square root 2 over 2, and square root 3 over 2. Or you can think of it as 1, 2, 3. So we're increasing 1, 2, 3. Of course, these ones have square roots over them, but you could think of the square root on the 1 as well, because square root of 1 is just 1. So moving up the circle, for the y-coordinate, we have 0, 1 over 2, square root 2 over 2, and square root 3 over 2. And then, of course, 1 up here. Okay, and don't forget that these all relate to sine of theta. So sine of 0 degrees would just be 0, or sine of pi over 6 is going to be 1/2. Sine of pi over 4, that's this angle right here, is square root 2 over 2, and sine of pi over 3 is square root 3 over 2. As for the x-coordinates in red, they just move in the opposite direction of the y-coordinate. What I mean by that is, for the y-coordinate, we had 0, 1/2, square root 2 over 2, square root 3 over 2, and then 1. Well, if we're moving down the circle, then we have the exact same points for the x-coordinate. 0, 1/2, square root 2 over 2, square root 3 over 2, and then 1. And don't forget that these also relate to cosine. So cosine of pi over 6 is square root 3 over 2, that's right here. Cosine of pi over 4 is square root 2 over 2, and cosine of pi over 3 is just 1/2. Okay, our next goal is to find 3 additional angles in each of the 3 remaining quadrants that correspond to the angles that we have already found. So here are the 3 additional angles in the second quadrant. And let me explain what I mean by how they correspond to angles in the first quadrant. So let's think about 30 degrees for a moment. So 30 degrees is 30 degrees above the positive x-axis. Well, over here we have 150 degrees. 150 degrees is 30 degrees above the negative x-axis, or it's 180 degrees minus 30 degrees. Minus meaning we're going in the clockwise direction, right? So the 150 degrees kind of corresponds to the 30 degrees. They're kind of similar in some respects. And that means that the point is also going to be quite similar. So the point at 30 degrees, or pi over 6, is square root 3 over 2, comma 1/2. Well, the point at 5 pi over 6 is still going to be square root 3 over 2, comma 1/2, but now the x-coordinate is negative, because we are to the left of the y-axis, where x is negative. And that's going to be the same case for the other corresponding angles. We have 45 degrees, which is the same thing as 180 degrees minus 45, going up 45 degrees. That would put us at 135 degrees. We're going to have the same coordinates, except for the x-coordinate is going to be negative. And same thing here for 120 degrees, corresponds to 60 degrees. And we're going to have the same point, but the x-coordinate here is going to be negative. The exact same idea is going to apply for the third and the fourth quadrants. We're going to have 3 angles that correspond to these 3 angles in the first quadrant. And here is what we will have. Okay, so for example, 210 degrees corresponds to the 30 degrees. Really, the term for that is a reference angle. The reference angle is the angle in the first quadrant that kind of corresponds to that value. In other words, we're going to have the same xy coordinates on the unit circle, except the signs might be changed a little bit. And that's exactly what we have here, right? We're 30 degrees here, and we are 30 degrees below the negative x-axis here, up to 210 degrees. And that means we're going to have the same coordinates, square root 3 over 2, comma 1/2, square root 3 over 2, comma 1/2. But here they're going to be negative. Both are going to be negative because we are below the x-axis, which means the y-coordinate is negative, and we are to the left of the y-axis, which means that the x-coordinate would be negative. And this applies to all of the other points here. So you should always be able to find the coordinate points by thinking about which quadrant are you in and what is the reference angle in the first quadrant. Now there's a saying out there that can help you remember where each of the trig functions are positive or negative, and also where we have either a positive or negative coordinate on the unit circle. They kind of go together, since the x-coordinate is cosine and the y-coordinate is sine. And that saying is, all students take calculus. Now, of course, this is not a true statement, but this is just a way to remember where we're going to have positives or negatives on the unit circle. And you can kind of already see this. We have in the very first quadrant here, it's all, which means that all trig functions and therefore all of our coordinates are going to be positive in the first quadrant. So see here, everything we have, all the coordinates are positive in the first quadrant. And that will also mean that cosine is positive and sine is positive, and also tangent would also be positive in the first quadrant. So all trig functions are positive in the first quadrant. The S for students corresponds to sine, which relates to the second quadrant. So it says that sine is going to be positive in the second quadrant, right? So the y-coordinate is sine, and we can see that it's positive for all of the points in the second quadrant. So if you're in the second quadrant, you are going to be positive for sine, and you're going to have a positive y-coordinate because we are above the x-axis. Cosine, on the other hand, is going to be negative, or our x-coordinate is going to be negative because we are to the left of the y-axis, which is reflected in the x-coordinates here. T is for tangent, and it says that tangent is positive in quadrant 3. So here we would be in quadrant 3, and if you were to take tangent, tangent of course is just going to be y over x, as we said before, or sine over cosine. If you were to divide these values together, you would get positive values for tangent, right? When you divide two negative numbers together, you would get a positive number. So anywhere down here, you would have tangent would be positive. Sine and cosine would both be negative, or your x and y coordinates would both be negative, but tangent would be positive. And then finally, in quadrant 4, we have cosine. We have calculus, I guess, is the word, which relates to cosine and says that cosine is going to be positive in the fourth quadrant because we are to the right of the y-axis. So that means we are in positive x territory. So you can see that the x coordinates are positive here. The y coordinates are negative because we are below the x-axis, but the x coordinates are going to be positive. So you can use this phrase if you want to help you remember when you will have either positive or negative trig functions. Okay, so the rest of this video we are going to spend practicing finding points on the unit circle given different angles. Okay, so typically you would want to do this with maybe only having the first quadrant of the unit circle. This is really the part that you should be memorizing, the first quadrant of the unit circle. So you should know all of the angles and the points on the unit circle. And as long as you know the first quadrant, you can always kind of derive the other values on the unit circle. I wouldn't memorize all of the values. I would just memorize the first quadrant. Okay, so you may be asked, for example, to find cosine of 315 degrees. Okay, so how would you do this? 315 degrees is not in the first quadrant. 315 degrees is somewhere in the fourth quadrant. It is somewhere between 270 degrees and 360 degrees. More specifically, it is exactly 45 degrees less than 360 degrees. Think about that. 360 minus 45 is 315. So that means our reference angle is going to be 45 degrees. So this angle would be right around here. It would be something like this. Our reference angle is 45 degrees, which means we're going to have the same x-coordinate, which is what cosine is. It's still going to be square root 2 over 2, but possibly the sign could be changed. By that I mean positive or negative. But if we think about this for a second, we are in the fourth quadrant, which is where the x-coordinate will be positive, right? We are to the right of the y-axis. So the x-coordinate is positive here. So we're still going to have square root 2 over 2. So cosine of 315 degrees will be square root 2 over 2. Okay, let's try sine of 240 degrees. Okay, so where is 240 degrees? Well, 270 degrees is right here, so 240 should be somewhere in the third quadrant. Okay, and 240 degrees more specifically is 60 degrees more than 180 degrees. 180 plus 60 would give us 240 degrees, right? So that means that our reference angle is going to be 60 degrees, which means that sine, which is the y-coordinate, will still be square root 3 over 2, but possibly the sign could be changed. Okay, and will the sign be changed? Yes, it will be, because we are in the third quadrant where sine is going to be negative. We are below the x-axis, so our y-coordinate will be negative, so it won't be square root 3 over 2, it will be negative square root 3 over 2. All right, how about sine of negative 30 degrees? Okay, this is something we haven't quite talked about yet, and that is a negative angle. So when you have a negative angle, that means we are not measuring counterclockwise, we're actually measuring clockwise. So this is going 30 degrees down the circle. Okay, So our reference angle for this is still going to be 30 degrees. This would be coterminal with 330 degrees. Hopefully you can see that. If you just add 2 pi to negative 30 degrees, you would get 330 degrees. Okay, so either way you want to think about it, we are 30 degrees below the positive x-axis. So the reference angle is going to be 30 degrees. Okay, sine of 30 degrees is the y-coordinate, which is 1/2. Okay, and sine of negative 30 degrees means we're down here, which means we're not going to be at 1/2, we're going to be at negative 1/2 because we are below the x-axis. So we will have sine of negative 30 degrees equaling negative 1/2. Okay, how about cosine of 180 degrees? Well, that's an easy one because it's a quadrant angle, right? 180 degrees is right over here. Cosine is the x-coordinate, so it's just going to be negative 1. How about sine of 135 degrees? So 135 degrees, let's just first identify which quadrant we're in. Well, 135 degrees is somewhere between 90 and 180 degrees. And more specifically, it is 45 degrees less than 180 degrees. So 180 minus 45 would be 135. So we would be right around here for 135 degrees. So the reference angle is going to be 45 degrees. And sine of 45 degrees is the y-coordinate. It is square root 2 over 2. Which means that sine of 135 degrees will also be square root 2 over 2 because we are above the x-axis. So that is going to be our answer there. Still going to be square root 2 over 2. It's going to be the same as our reference angle. How about cosine of 210 degrees? So 210 degrees is somewhere between 180 and 270 degrees. More specifically, we are 30 degrees below the negative x-axis. So our reference angle is going to be 30 degrees. Cosine of 30 degrees is the x-coordinate, which is square root 3 over 2. But since we are in the third quadrant, cosine is going to be negative because we are to the left of the y-axis where x is negative. So this will be not positive square root 3 over 2, but negative square root 3 over 2. Let's try a few problems in radians. Let's say we are asked to find sine of 7 pi over 4. Now the way I think about radians is I think of splitting the top half of the circle into however many pieces are designated by the denominator. We are splitting the top half of the circle into 4 quarters. Okay, so pi over 4 is right here. This would be 2 pi over 4, or pi over 2 if we reduced. This would be 3 pi over 4. This would be 4 pi over 4, or just pi. This would be 5 pi over 4. This would be 6 pi over 4, and this would be 7 pi over 4 right here. So this is 7 pi over 4, our angle here. And it's a little bit easier to find the reference angle when you're dealing in terms of radians, because just find the other angle that has the same denominator. That will typically work, right? Which means the y-coordinate will be the same at 7 pi over 4 as pi over 4, but the sign may be flipped. Okay, so at pi over 4, the y-coordinate is square root 2 over 2. At 7 pi over 4, we will be in negative y territory, right? So it's going to be negative square root 2 over 2. How about 2 pi over 3? We want to find sine of 2 pi over 3. Okay, so 2 pi over 3, think of splitting the top half of the circle into 3/3. So here is pi over 3. 2 pi over 3 would be right around here. 3 pi over 3 would be pi, basically, right? So we want to find sine of 2 pi over 3, that would be right here, okay? So the reference angle is going to be pi over 3. Sine of pi over 3 is square root 3 over 2, our y-coordinate. And at 2 pi over 3, we will still be positive for our y-coordinate. So sine of 2 pi over 3 will still be square root 3 over 2, just like our reference angle. How about cosine of negative 2 pi over 3? So now we're moving in the negative direction. This would be negative 1 pi over 3. This would be negative 2 pi over 3 right here, okay? The reference angle would just be pi over 3. And the x-coordinate for pi over 3 is 1/2. So cosine of pi over 3 is 1/2. Cosine of negative 2 pi over 3 is going to be, well, we're going to be in negative x territory. So it's going to be negative 1/2. How about sine of 3 pi over 2? Okay, so pi over 2, this is pi over 2. Here's 2 pi over 2. Here is 3 pi over 2 down here. So sine of 3 pi over 2 is the y-coordinate. This is a quadrant angle, so the answer is just negative 1. We have that right on our circle. How about cosine of 3 pi over 4? Okay, so 3 pi over 4, here is 1 pi over 4, 2 pi over 4, 3 pi over 4 would be right here. So the reference angle is going to be pi over 4. The x-coordinate is square root 2 over 2. But if we're over here in quadrant 2, then cosine is going to be negative because we are to the left of the y-axis. So it's not going to be positive square root 2 over 2. It would be negative square root 2 over 2. How about cosine of 5 pi over 3? So here would be 1 pi over 3, 2 pi over 3, 3 pi over 3 would be pi. 4 pi over 3, 5 pi over 3 would be right here. The reference angle is going to be pi over 3. Cosine of pi over 3 is the x-coordinate, which is 1/2, which means we will still be at 1/2, but possibly negative, but we're not going to be negative because we are to the right of the y-axis, right? In terms of our x-coordinate, we are going to be positive still. So we will have cosine of 5 pi over 3 will be positive 1/2. Okay, that completes all the examples I wanted to do in this video. Over the next several videos, we will practice using the unit circle quite a bit more. And you will use this unit circle, like I said, throughout the rest of your trigonometry class. So the best thing you can do for now is to memorize the very first quadrant of the unit circle. So the way that I suggest you do this is maybe every day or every other day, see if you can recreate the first quadrant of the unit circle. See if you can create the angles and also the points on the unit circle. And also remember that cosine of theta is the x-coordinate and sine of theta is the y-coordinate. And if you have all those things, you are setting yourself up for success in this class.